Hello, Algebra 2 students. In this video, you're going to use what you learned in the previous video about rewriting from log to exponent. The reason we do this is because that changing from exponential form to logarithmic form allows you to isolate the exponent. If you remember in that previous video, we had a problem that was 2 to the power of x equals 20. And we needed to know how to solve that because we can't write it with the same base. 20 can't be written as a power of 2. 2 can't be written as any other power. So just as a brief reminder, here we go. 2 to the power of x equals 20. If we're trying to solve, we need to isolate this exponent that is the variable. So if we change that to a logarithm, remember the base goes here, the exponent goes to the other side. Now this x is isolated. Right now with this video, we're just rewriting from log to exponent or from exponent to log. I think these are all log to exponent. We're just rewriting. And then in the next couple of days, we'll learn how to use that to solve, okay? So here we go. I'm going to give you a couple of these examples. They're really pretty easy. If you need a reminder, this tells you if the x is in the exponent, what to do. If the x is in the base, what to do. If the x is the answer, what to do. Notice your directions say to rewrite each equation, then find the value of the variable. I'll also attach your powers chart so that you can use that if you need it. You'll notice in the first few ones, they give you a template, like a number goes in this box, a number goes in this box, and a number goes in this box. Once you get down here, it's the same type of problem. They just figure by now you know where to put the numbers. You don't need the box anymore. Okay, now, so let's look at this one. Log base 9 of x equals 3. We're going to rewrite it and then figure out what x is. So when we rewrite it, this base, the 9, goes here, kind of makes a circle. That exponent is the one that's isolated. So 9 to the third power equals x. That means 9 times 9 times 9, which is 729. Okay, that one's not on your powers chart, but you could use a calculator and do 9 to the third power, or you could use a calculator to do 9 times 9 times 9. Look at the next one, b. The base is 3. The exponent is x. And the argument, or the other number over here, is 9. That goes in this box. Now, most of you can look at that, and if we go 3 to the power of x equals 9, what number do we raise 3 to? What power do we raise 3 to make 9? It's 2. If you don't know that by looking at it, think about 3 to the first power is 3. 3 squared is 9. There it is. If you needed to, you could keep going. 3 to the third is 27. But what we're looking for is that 9. So we know that x is 2. Okay? What I'd like for you to do is pause this video, work out these others through like G, and then turn the video back on and you can check your answers. Okay? And then you can take a picture of your work and send it to me. You can work this. I'm going to attach the PDF, but you can work it on your own paper if you want. All right, C. Hopefully you paused the video and now you're back, and let's see how you did. This base is x, this exponent is 3, and this argument or number is 64. So my equation I have here now is x to the third equals 64. I can either look at my powers chart, or I can take the cube root. X is 4. Okay, for letter D, the base is 7. The exponent is 4. And the base, or the number here, is x. So I need 7 to the fourth power. And 7 times 7 is 49. 49 times 7 is 343. So this is to the second power, right? Add one more, that's to the third power. I need one more. So 343 times 7, or you can use a calculator. 2401. Right. I didn't want to change screens or get a calculator, so I just did 7 times 7 is 49, so that's squared. Multiply that times 7, that's 3. Multiply one more 7, that's 4. Letter E, x to the log x of 32 equals 5 over 2. The base is x. The power is 5 over 2. That doesn't look like a power. Let's redo that. If you remember when previously this year we solved equations with rational exponents by raising to the reciprocal power. So if I have x to the power of 5/2 equals 32, to get rid of that, I'm going to raise this to the 2/5. Just flip that fraction upside down. That's the reciprocal, because when you multiply these, they cancel out. Now, if I did that on the left side, raise that to the 2/5 power, I've got to raise this to the 2/5 power. So now I have x equal, you can use your calculator, or remember, this is the root number because it's on the bottom. It's the 5th root of 32 squared. Using the powers chart, 5th root of 32 is 2. 2 squared is 4. This one we talked about, if a common log, if there's no base written, that's understood to be a 10. The base is 10. So this is 10 to the power of negative 4 equals x. You can use a calculator and get 1 over 10,000. Or you can think scientific notation. Times 10, 1.0 times 10 to the negative 4th. So you would take your decimal and move it 4 times. 1, 2, 3, 4, 0, 0, 0, 1. This one is almost the same. You got 10 to the power of x equals 10,000. If you think about your decimal here, we move it 1, 2, 3, 4 places. Okay. Or you could, what else could we do? 10 to the power of x equals 10,000. You could write, this is 10 to the 4th. That has to all do with your scientific notation. This one, the base is 9. The exponent is x, 1 over 81. 81 is 9 squared. When do we put a 1 over with exponents? We put a 1 over with exponents when they're negative. So we have 9 to the power of x equals 9 to the power of negative 2. The bases are the same. The exponents are equal. And we're done. Okay? Rewriting from logarithm to exponent. Okay, these deal with an exponent rule I'm not sure that we've covered. I don't know if you remember that from your previous math classes. But anything to the 0 power is 1. So if I had x to the 0 power, it's 1. If I have 12 to the 0 power, it's 1. If I have z to the 0 power, it's 1. If I have 1,537,253 raised to the 0 power, that's 1. Anything to the 0 power is 1. So this is 4 to the 0 power equals x. 6 to the 0 power equals x. Now look at this one. If we rewrite this one, it's 8 to the power of x equals 1. Over here, we had our x is 1, so this was 1. This one, x was 1. So what do you notice there? 4 to the 0 power is 1. 6 to the 0 power is 1. If 8 to the power of x is 1, that x has to be 0. And here, 10 to the power of x equals 1. What power do we raise something to make it equal to 1? It is 0. And that's that. Thank you. Have a good day.